So I'm going to suggest that you always start by rewriting the fraction without the integral sign. And let's factor this out. So if I factor out an x, I'll get x squared plus 3. All right, so now you can see that this is a linear factor, so that's going to get an x. And then this is going to be a quadratic factor, irreducible, right? Cannot be factored anymore. So that's where we get the bx plus c over the x squared plus 3. All right, so I'm just going to put some parentheses here. So we're multiplying both sides by x times x squared plus, whoa, sorry about that, x times x squared plus 3. There, x squared plus 3. Okay, so these cancel, right? So on this left-hand side, I get x squared minus x minus 6. Let me write that again neater. So I have x times x squared plus 3. So I'm multiplying by this denominator. So then multiplying this times this, the x's cancel. So I'm left with, get rid of that noise. I get a times x squared plus 3 plus. Now when I multiply this term times this, I get bx plus c times x. Be really careful that you keep the parentheses there, right? Okay, so now we have one good number to choose, right? The one good number would be x is equal to 0, because if I put in x equals 0, this goes away. So when x is 0, I get negative 6 is equal to 3a, so that means a is negative 2. So now there are no more good numbers. So this is where you want to compare coefficients. So I'm just going to rewrite this down here. And I'm going to put the a in. Why not? We know it, right? So it's negative 2. And then I've got this bx plus c times x. So I want to make sure that you're careful. I'm going to suggest even that you multiply this right-hand side out. Negative 2x squared minus 6 plus bx squared plus cx. And then I've got this over here. So I've got two letters to solve for, both b and c. So let's think about it. I'm looking at b, and it's in front of an x squared term. So let's compare the coefficients of x squared. On the left-hand side, I have a 1, right? There's a 1 there. On the right-hand side, I've got negative 2 plus a b. Oh, well, that must mean b is equal to 3. All right, so now let's look at the x terms, so the x coefficients. So the x coefficients on the left-hand side is negative 1, right? Negative 1 right there. And over here, it's c. So there we have it. We have all of the letters. Okay, so c is negative 1, b is 3, and you need to have this saved nice and neat so I can plug these three things, this, and this, back in. All right, so now I'm going to take liberties here, make some erasures so I can fit it in. Okay, so I'm going to plug it back into the integral. Okay, so I'll have integral of a, which is negative 2 over x, plus b, which is 3x, minus a c, which is 1, over x squared plus 3. Okay, so let's think about it. We got addition, so I can separate the integral around the addition. So I can say that this is the integral. Well, I think we can just do this integral, can't we? Isn't this just negative 2 times the ln of x? Plus, okay, so let's stop and think about this one. Remember I mentioned that this is a not very profound, but a very important step. So I'm going to separate this around the subtraction in the numerator. And I'm going to make it two separate integrals. Okay, so then let's look at this one. Oh, I see. Easy u. Easy u is the denominator. Du is 2x dx. So let's go through all the details. So let's carry this guy along. So here I would get this 3 and this 2. So I get a plus a 3/2 integral of 1 over u du minus, do you recognize this? This is arctangent. So arctangent where the a squared is 3. So that means a is 1 over root 3, arctangent x over root 3 plus c. And so to finish it off, keeping all organized here, not that one, negative 2 ln of x plus 3/2 ln of u, which is x squared plus 3, minus 1 over root 3 arctangent of x over root 3 plus c.